Hello, this is Daniel and Mohammed. We've been working on a deep learning project for speech signal processing with the aim in the future to improve hearing aids. There are two ways to accomplish this, through speech enhancement or sound source localization. In our project, we focus on the latter, and for either one, since this is a deep learning project, we require lots of data.
So in terms of the data collection process, we have 6 speakers in an anechoic chamber, each of them being separated 60 degrees apart. And in the center of the room, we have a chair in which a microphone is perched up from the seat 23 inches above it. The microphone is aligned directly in front of each of the speakers, and there's a 7th microphone right in the center. 2 opposing speakers are 8 feet apart, so that means the microphone would be at the 4 feet mark. So here's a picture of the anechoic chamber. In the center is the chair, and right here is the stand that we made. You'll notice that the walls and the floor as well are covered in foam. These are perpendicular to each other, so that when the room is closed, this is a door on the left, when this is closed, there would be no reverberations coming out from the speakers as it travels in this room. That is so that we can capture each individual speaker being directly in front of a specific microphone. So these are the microphones that we're using. There's 3 of them right here, and this 4th one here, and there's 2 more behind this picture. We're not using these microphones on the top here, but yeah. So this is a close-up of the microphone. On the left is the top, and on the right is the bottom.
For a deep learning model, we decided to use a convolutional neural network for sound source localization. As you can see here, this is showing the first 4 convolutional layers consisting of 3x3 filters. They are exponentially increasing, the first one having 32, then 64, then 128, then 256. The reason to use CNNs for sound source localization, which can sound a little bit unnecessary, is because we are not using raw audio signals. We are actually using Mel filter substrate coefficients as spectrograms, like you can see on the picture on the left. This is a normal raw audio signal. We are actually using an image like this. Not quite an image, it's a concatenated array, which we are using the 7 microphone channels to generate, and we're using the convolutions to filter through this image and then into the flattened and dense layers to output a category of cross entropy across the 6 speakers. We still have lots of work to do. We need to tweak the network further, gather more data to increase the diversity, and further develop a second model to improve hearing aid.